Hello everyone. So last time we learned linear regression, predicting numbers like pizza prices, right? Now today we'll be doing something different. Okay? So the topic is logistic regression. Name is regression, but it is actually a supervised classification model. Okay, it is a supervised classification model where your dependent variable is categorical, okay, or binary. Dependent variable is categorical or binary. Binary means 0 1 like that, right? Now what exactly is logistic regression? Like, why do we need it? For example, a basic classical example, that is your Gmail. In your Gmail you have a folder called spam folder, right? A spam folder section is there, but how do we know that the mail is spam? That's why I said this is a supervised learning. If you would have seen my first lecture, I have clearly explained supervised learning is when the learning takes place under guidance, okay, under guidance. So now whenever you receive a mail and model identifies it to be a spam, then it puts it under the category of spam and one category not spam. So whenever you have to predict something, either 0 or 1, yes or no, true or false, in that scenario you have to use logistic regression. Okay, now as I talked about real life example, but what is the formula? How do we compute it? So first thing, mathematically logistic regression predicts the probability of category using sigmoid function. What is sigmoid function? We'll be coming back to it later part of the video. First let us see what is the formula. So probability, okay, you have to predict a probability. So 1 divided by 1 plus e minus a naught plus a1 of x. What is a naught, what is a1, what is x? We will be looking that in the later part of the video, but right now there is a common misconception that many of us have, that is like student often think linear regression can be used for yes no problem, right? But linear regression might predict number like 1.3 0.2. that doesn't make sense for categories. What did I say? See, linear regression, right now we are studying logistic. Linear regression can also predict quantities like 0.2 0.9. Then why not we, if we will set a threshold, and we'll put it into that category. See, that doesn't mean that always it comes under the category of 0 to 1, right? It can exceed, it can go as 1.3 also. So that doesn't make sense for categories. So for solving that concept, we use logistic regression. Okay. Now, you imagine predicting whether a patient has diabetes. Okay. Now you have to predict whether the patient is having diabetes. Okay. So what could be your inputs? Your inputs could be age. What's the age of the patient, right? Your input could be sugar level, then maybe blood pressure, right? And the output will be yes or no. This will be your output. Okay. Here logistic regression gives us a probability of disease. Okay, it will give you a probability of the disease. Okay, then we decide, now we will put a threshold. Okay, we'll put a threshold if the probability exceeds 0.5, say suppose 0.5. okay, then you put it into a category of yes, that yes, the person is having diabetes. Say for example, your model says 0.8, so you will say yes. If the model gives 0.2, you will say no, yes diabetes, no diabetes. Okay, so dependent variable is equal to categorical 0 or 1. Independent variable is equal to feature used to predict outcomes. Now some students might think logistic regression can only handle one input. It's not like that. Actually we can have multiple feature, that is called multivariate logistic regression. Okay, but you would have a doubt, why not linear regression? So why not just use linear regression? Well, linear regression predicts number, like as I said, it will predict number like 0.7, 0.2, negative of 0.2 or 1.3. But for yes or no question, like if you want to answer yes or no, your value must be between 0 and 1, right? Then only you can set a threshold and get. So for solving this problem we use sigmoid function. Okay, we use sigmoid function. So how do you write sigmoid function kind of thing? We'll get on to that part. So maybe you would be confusing thresholding in linear regression. See, thresholding alone doesn't fix the probability issue. The output can still exceed 0 and 1. That is the thing which we need to understand. Okay, that is the thing which we need to understand. Okay, now what is sigmoid function? So sigmoid function, I have written the definition. The sigmoid function, also called logistic function, converts any output negative infinity to positive infinity into a value. Fine, I'll tell you. Converting any value to probability. This is the task. This is what sigmoid function will do. So like think sigmoid function is like a dimmer switch. Okay, dimmer switch, dimmer switch. It takes any number, big or small. Okay, big or small, negative or positive, and convert it into a probability of 0 or 1. For example, we'll take a easier example. Hours studied. If you study hours studied is equal to probability of passing exam. Right? Hours studied is equal to probability of passing exam. Now if you study less, few hours, then you might go below the threshold. And then which will be closer to 0. Okay, if you study more, you will be above the threshold, so it will be near to 1. Okay, so let us understand from a graph. If your graph is like this, okay, this is your hours studied and this is your probability. Maybe your threshold is here, So if I study more, then the chances of me passing also increases, right? That is what, like, sigmoid function is like simply converting any value to probability. Okay, so now what is now sigmoid function? Okay, what is the formula? Now we'll see that. Now that you have got a basic overview about how things are happening, now we can move on to the formula. So the formula is, sigmoid function formula is this. You might have seen this formula just now, where your z is nothing but a0 plus a1x. Okay, understood? Now if z is 0, you get sigmoid as 0.5. If z is infinity, you get 1. What is z? How are we getting those values, 0, 1, everything? Let us see. Now if I put my z as 0, okay, so sigmoid of 0 would be equal to 1 by 1 plus e power 0. This will give me a probability of 0.5. That is our threshold. Now say suppose our value of z is equals to infinity. Okay, is infinity. So this would be 1. So can you see how it is converting any input that is from positive infinity to negative infinity into a 0 and 1 value, in between 0 to 1. Similarly, if you put minus infinity, it will give you 0, right? So you can see that any value from minus infinity to plus infinity, if I give inside my sigmoid function, it will return me a value between 0 to 1. So you can basically understand it in this way. if your sigmoid of x is greater than equal to 0.5, maybe you will put it in predict in class 1. If it is if it is less than 0.5, you might put it into class 0. In short, sigmoid function is the link between linear models and probability, making logistic regression useful for classification. Right? Now what is the formula for logistic regression? Same as sigmoid function. Okay, it is the same formula. Okay, it is the same formula. Here we write z, and now what is z? Z is actually this. Now your a naught is the baseline probability or intercept. It is the intercept or baseline probability. Your a1 is how strongly the input influences the probability. You can call it as coefficient. Okay, so a1 is something like how strongly the input influences the probability. You would have done, right, column analysis impact, something like that, column analysis impact. So we get to know that how strongly that input particularly influences the probability. If you see a data set, there are certain columns that would impact the output nicely, right? And x is your independent variable. As we know, x is your independent variable. Now basically what we have to calculate, you have to calculate z. You have to calculate z only to predict. Okay, you have to calculate this thing. Once you calculate this thing, you are ready to plug in and play, right? Now, and once you plug in play inside, if you put this value inside your sigmoid function, you get something between 0 to 1. Now sometimes people confuses probability with class label. Remember, probability is a decimal, class label is 0 or 1 based on the threshold. User has the capacity to decide the threshold. Okay, probability is coming 0 or 1, that doesn't decide the class, right? So once we have the probability, we decide which class we have to put. That is where thresholding comes. You set a threshold. If I set a threshold as 0.9, and if it is 0.92, then only I'll put in class 1. But if I set the threshold as 0.5, and if I get a value of 0.7, again I'll put in class 1. So it depends upon the threshold that you set. Okay, so this is what thresholding is. Threshold can be adjusted. 0.5 is a standard, but sometimes if we want stricter or lenient, depending upon the application, if you want it to be very strict, I'll put the threshold as 0.9. If I want it easy, I'll put it as 0.5. Now let us work out an example. Okay, example. Now you can see I have a small data set, x and y, hours of study and whether they are pass or not. 2 hours of study, not pass. 4 hours of study, not pass. 6 hours study, pass. Now how are we getting these values? Okay, how are we getting this value? How are we actually doing? Now assume you have a naught as -4, a1 as 0.8. Now for x equals to 5, say suppose a student who has studied for 5 hours, we have to find whether they will pass the exam or not. Okay, they'll pass the exam or not. Now if I put it inside the function, z is equals to -4 plus 0.8 into 5. This is actually a1 x plus your a naught. This is your z, right? This is your z. So now I see my z value is something around 0. So if I put p is equal to y plus 1 by 1 plus e power minus z, so I would get 0.5. So if my threshold is 0.5, I would say okay, predict 1, means the kid will pass the exam. Now for example, if the kid has studied only for 3 hours, then what is our z? Z will be 0.8 into 3, which is 1.6. Now if I put this inside my p in my formula of sigmoid function, it it would be something 1.6, and then this will give you 0.17. So it is below our threshold of 0.5, so we'll say the kid will fail, that is 0. This show how logistic regression again assigns probability based on input, then threshold convert it into a prediction. So what is happening? You have certain input x, it you compute the z, then it passes through sigmoid function, and then you get a probability p, you check the threshold, and according to that you decide class 1 or class 2 or whatever class it is. Okay, decide that. So if you want a graph visualization, again like this, you plot a graph. Okay, and this is a threshold of 0.5, and if it comes somewhere over this, this will be class of 0 and this will be class of 1. Okay, this curve shows probability of passing changes with hours studies. Okay, this will be your hours studied and this is your probability. Okay, so I hope you have understood. If there is any doubt, you could ask me in the comment section. Thank you so much.